Soil health. You may have heard this term for the first time in the past few years and wondered, what does soil health mean? According to the USDA and RCS, soil health is defined as the continued capacity of soil to function as a vital living ecosystem that sustains plants, animals, and humans. To further understand soil health, it is important to note that soil has three components: the physical component, the chemical component, and the biological component. When these three components are all in good condition, then the soil can be considered healthy. Now, each of these components are made up of several different properties, but this video will discuss one important physical property of the soil: bulk density. Bulk density is defined as the mass of oven-dry soil solids per unit volume of soil. It is typically reported in grams per centimeters cubed. To calculate the bulk density value, we need to collect a known volume of soil, dry it, and weigh it. A bulk density sampler probe can be used to collect soil cores for these measurements. When the probe is driven into the ground, the sleeve that was placed inside of the cup holds the soil intact. After removing the sleeve from the cup, the excess soil is removed from the top and bottom so that it is perfectly level with the sleeve. Once the soil core is collected and all of the excess is eliminated, take it back to the lab and carefully remove all of the soil from the sleeve so you don't miss any of it. You will then dry it at 105 degrees Celsius for 24 hours. Now we will talk about bulk density calculations. The first thing we need to know is the volume of the cylindrical sleeve used to collect our soil. To find the volume of the sleeve, we will need to know its diameter as well as its height. For this particular sleeve, the diameter was 2 inches and the height was 2 inches. Because we know that bulk density is reported in grams per centimeters cubed, let's convert our inches to centimeters. We know that there are 2.54 centimeters in 1 inch. So when you do the calculation and you multiply the 2 inches by 2.54 centimeters, the inches cancel out and you end up with 5.08 centimeters for both the diameter and the height. Now that we have our diameter and height in the correct units, we can look at the formula for the volume of a cylinder. Volume is equal to pi times r squared times h, with r equaling the radius, which we know is half of the diameter. So r equals 1/2 times 5.08 centimeters. This is equal to 2.54 centimeters. Now we can plug everything into our formula. Pi times 2.54 centimeters squared times 5.08 centimeters. Once we square the 2.54 centimeters, we get 6.45 centimeters squared. After multiplying that by pi, we get 20.3 centimeters squared times 5.08 centimeters, for a total volume of 103 centimeters cubed. From the definition of bulk density, we know that it is the mass of soil solids over the volume of soil, and we now have the volume of soil, which is 103 centimeters cubed. So now let's look at our dry soil and determine its mass. Awesome! Now that we have our mass and our volume, we can calculate bulk density for our soil core. If we divide our mass, which is 158.9 grams, by our volume, which is 103 centimeters cubed, we find that the bulk density for our soil core was 1.54 grams per centimeters cubed. Great, so now we have our bulk density value, but what does it mean? Bulk density is an indicator of soil compaction and has direct effects on root growth, infiltration, porosity, and even microbial activity. The general range of bulk density for mineral soils is anywhere from 0.8 to 2.0 grams per centimeters cubed, in which the soils falling at the lower end of the range, while not always, generally have a higher amount of organic matter and greater water infiltration, while soils at the higher end are known for having very compacted soils. In general, soils with bulk densities higher than 1.6 grams per centimeters cubed will restrict root growth and potentially hinder plant productivity. Naturally, you may start to wonder what increases soil bulk density. Several practices in agriculture can be attributed to an increase in bulk density, such as repetitive tillage, which causes a loss of organic matter and the disruption of soil aggregates, growing the same crops year after year, which means there is a lack of diversity in root lengths throughout the soil, as well as the continual removal of residue after each crop season. Some management strategies to combat the increase in soil bulk density are crop rotations and the planting of cover crops, as these will both increase the diversity in root lengths, which can break up compacted layers within the soil. Another strategy is limiting the number of trips across the field in heavy equipment and only making those trips when the soil is adequately dry to reduce compaction by the tires. Now that you know the methods to measure soil bulk density and the importance of managing this physical property within the field, you are one step closer to ensuring that soils remain a sustainable ecosystem for plant, animal, and human lives for years to come.